Good evening, all of you. So, those students who are present, kindly write your name in the chat box. Voice coming to everyone clearly? Okay. So, I am Jitendra Tyagi, and in this class, what I am going to do right now, as you all know, daily we are conducting live classes on this time on our YouTube platform for NIC exam. Okay. So MCQs we are taking for which are helpful for your upcoming NIC exam. Okay. And today it is turn of digital electronics. So I will discuss different MCQs from digital electronics. Okay. So those who are present in this class, what you have to do with me, you will see a question on the screen here. Okay. And you have to try to find out the solution of that question immediately. And please write that answer. Okay. Which answer you are getting in the chat box. Okay. Please respond in the chat box. Okay. And then I will explain you the solution of the question. Okay. So different questions from different chapters of digital electronics we are going to cover in this class, right? So it is one kind of quick revision. Okay. All the things will get revised and you will get idea how you are able to solve the questions or not. Okay. So let us see our first question here from digital electronics. So this from number system, we can say conversion. Okay. What is the answer? Please write in the chat box immediately. All of you compute the answer and write your answer in the chat box. To give response in the chat box is very important, so that I get idea how many students are able to solve the question. We have to find the binary equivalent of the decimal number 137. Okay, so 1, 2, very good. Akash Malik, Roshan and SSJ are getting B answer. Okay, so in this exam, in digital electronics, number system is always important. So you should learn different conversions, okay, to convert one number from another number, right? So decimal number we have, decimal to binary conversion we have to make. So we have a successive division method. All of you know, we can divide by 2 because we are going to convert it in base 2. So we can divide this number by 2. That is one method. Another approach is also there, which you can use. 137, we have 137. So we all know powers of 2 raised to the power 0, 1, 2, 3, all 2, 4, okay, 8, 16, 32, 64, 128, 256, 512, 1024. These are all powers of 2. Okay. So what will we do? We will break this number into different numbers. We will write their sum and we will only write the powers of 2. Okay. The terms which contain powers of 2 only. Okay. So we know 2 raised to the power 7, 128, you all know. So 128, this can be written here, plus if we add 16, it will go beyond this, it will become more than this. So if we add 8 plus 8, okay, so it is 136 or plus 1. So this number can be broken in this form. All the three terms are containing powers of 2. Okay. So this can be written as 2 raised to the power 7 plus 2 raised to the power 3 plus 2 raised to the power 0. Okay. Now start from the largest power. Okay. So 7 is present here. So the power is present. Then you have to write 1. If power is missing, then you have to write 0. And you have to go up to 0. Okay. Power 0. Right. So 7 is present. So 1. 6 is not present. So 0. 5 is not present. 0. 4 is not present. 0. 3 is present. So 1. 2 is not present. 1 is not present. 0 is present. So this will be the required binary number. Okay. So B answer you are getting here. That is the correct answer to convert the decimal number into its binary equivalent. Okay. So you can use, it can save your time. Suppose we have 515. Suppose I ask you that we have a decimal number 515 and we want to write it into binary. So if we divide by 2, then it becomes longer. Okay. But if we know the powers of 2, okay, so we can easily solve this problem. So 515. Okay. So we know that 512 comes in powers of 2, right? 512. So this can be written as 512 plus 3 is remaining. So that can be written as 2 plus 1. So we can say it is 2 raised to the power 9. 512 is 2 raised to the power 9. Okay. Plus 2 raised to the power 1 plus 2 raised to the power 0. So this number can be expressed in this form, right? So equal to, now starting from power 9, okay, 9 is present. Now 8 is missing, okay, 8 missing, 7 missing, 6 missing, 5 missing, 4 missing, 3 missing, 2 missing. Now 1 is present, so 1, 0 is present, so 1. So this will be the binary equivalent of this number. Okay, so you can use this method to convert decimal numbers into their binary equivalent. Now I recommend you people, please go through all the conversions. Okay, you should learn to convert one number from another number. Okay, another base, from one base to another base. This is important. One question you may get. Okay, now come to next question. So in the circuit shown below, P and Q are the inputs. This is P input and Q input. Okay, the logical function realized by the circuit shown is, okay, so it is circuit of a multiplexer. Here I0 is connected with ground, I1 is connected with P, select line is connected with Q, and you have to tell Y equal to. So what is the answer? Kindly calculate the answer and write it in the chat box. Very good. So Asif is getting a, SSJ, Roshan, everyone who is present should write the answer. Okay. So this multiplexer is also very important for your exam. You should know how to derive the output of a multiplexer circuit. Okay. So if we have a two input multiplexer, if we have a two input multiplexer having 0 and 1 input, I0 here and I1 here, and this is select line S. Okay, select line suppose S. So how do we write the output of this multiplexer? It is written as Y equal to S bar I0 plus S I1. This is the formula to write the output of the 2 by 1 mux. Okay. Now I0 is 0 because it is connected with ground. So 0. So S bar, S is what? S is Q. Okay. So we can say Q bar into 0. Okay. Plus, now S is Q and I1 is what? I1 is connected with P. Okay. So 0 into something 0. So we get PQ, QP or PQ. This one. So A is the right answer here. Okay. Output of the multiplexer. Now what you have to do at your home, 4 by 1 mux, you should write output expression. Okay, Y equal to, there you will have two select line S1 S0. So how to write the output? Okay, 8 by 1 mux, in that case also you should have practice of writing the output. They will give you input connections, select line connections, and you have to calculate the output, final simplified output, or in canonical form. Okay, different ways they can ask. So multiplexer is important. Okay, definition of multiplexer, and multiplexer as a logic function generator. Multiplexer can be used to generate different logic functions. Okay, all the Boolean functions, all the logic gates can be implemented using multiplexer ICs. So you have to revise that concept also, right? Now let us see our next question. So simplify the following Boolean function. What will be the simplified output, okay, of this Boolean function? So all of you compute the answer. Everyone should try to solve the problem. So which one will be the right answer? You have to write. So minimize, actually we have to calculate the minimize expression, right? So some students are writing answer as option A, but if you make the K-map, minimization is best done using K-map. So try to make a K-map and then try to simplify this and then tell me the answer. Please, all of you do this. Make a K-map, okay? And then minimize using K-map and tell me what answer you are getting. So now Nidhi Kumari is answering as option number C. Other students, please check. So Nidhi is getting C answer. Other students, okay, Asif Nadeem is also getting C answer. So here, this may lead to some problem. Okay, most of the students are writing A answer here. Okay, because this term is here, A bar, A B bar C is here, and they have taken A B as common. C bar plus C is 1. So A B. This is equivalent to this one. Both are equivalent. Okay, but they want simplification, simplified. So simplification is done using K-map. Okay, minimum expression we can obtain using K-map. So if we make the K-map, then we get the minimum expression, this one. Okay, so if we see the K-map here, let us draw. So we have 3 variables, so 8 cells will be required in the K-map. So we have 0 0 gray code, 0 1 1 1 1 0. This is called gray code, 0 1, right? Then we have A B and here C. So we are having A bar B C. A bar B C matlab what is the code? So 0 1 1. Okay, 0 1 1. So here 1. Then 1 0 1. So 1 0 1. Then 1 1 0. Then 1 1 1. Okay, remaining will be 0. So this is the K-map for this expression. Okay, canonical expression. Now if we try to make the groups, what we get? We are getting different groupings. So here a pair is there, this is a pair, and this is a pair. Okay, there are 3 pairs, and we can see that all the 3 pairs here are essential. Okay, none of them is redundant. So we have to write each pair. Okay, so now what is the, whenever we make grouping of 1, okay, जब भी हम 1 की grouping करते हैं, what we get a product term. Okay, whenever we do grouping of ones, we get a product term, and the resultant expression is a sum of product, SOP. So here this is a pair. So what is the common code? 1 1 A1 B1. Okay, so AB, we will write AB plus, if we take this pair, so what is the common code? 1 is common, so B, and here C, so BC. Plus in this pair, here A is common, here C is common, so CA. So this is the minimized expression from this. Okay, so please be careful. In case of minimization, better to use K-map. Okay, now come to next question. So tell me what is the right answer here. Okay, such question also you may get in your exam. No, simplify, yes, in case of, if they have given both the terms, na, A option was equivalent to that. Okay, and another option is also equivalent to that, but that is minimum, so that we have to take. Okay, in such situation. Simplify means minimum we have to try. Okay, yes, SSJ, clear, Mr. SSJ. Okay, so this is a logic gate. A bar A, B bar, A, B. These are the inputs here. Okay. And this is a bubble. This is a bubble. Now you have to tell the expression y equal to. So we are getting different answers in this question. Some students are writing B, someone writing D. All of you try and simplify this. Tell me the right answer. Then I will explain. Okay. So what we can do here? Are you trying or all done? First of all, this is a NOR gate. NOR means OR plus NOT, right? So A plus A bar, we know that A plus A bar is 1 and its complement is 0, and then we are having further complement, so 1. Okay, input of this AND gate here is 1 actually. 1 is going inside the AND gate. And here we have AND gate, so AB bar. So this input is AB bar, right? A, B bar. So this AND circuit will do what? A, B bar. It will give us A, B bar. Now here it is AND gate, so AB. Now this is AB plus AB. AB plus AB is AB, its complement. Okay. AB whole complement. So Y equal to what? Y equal to AB bar plus AB whole bar, right? Equal to AB bar plus, now here we can use De Morgan's theorem. So A bar plus B bar. Now from these two terms, we can take B bar common. Okay. So if we take B bar common, what we get? A bar plus 1. So 1 equal to what? Taking B bar common. Okay. So A plus 1 or plus A bar equal to, now 1 plus A is 1 and B bar into 1 is B bar. So finally we are getting B bar plus A bar, which can be written as A bar plus B bar because OR operation is commutative. So D is the right answer here. Those who got the answer, that is correct. Nidhi and SSJ and Asif has deleted his answer. Okay. So now in your exam, such question may come where you will get a circuit in which there will be different logic gates and you have to calculate the final output of the circuit, a combination circuit. Okay. So such question may come in your exam. Please keep in your mind. Okay. Now come to next problem. Simplify the following Boolean expression using the De Morgan's theorem. So they have mentioned that you have to make use of De Morgan's theorem. So which is the right answer you are getting here? Tell me that answer. So all of you compute the answer and tell me your answer. Okay. So now all done. C. Okay. So Nidhi, what is your answer, Nidhi? So De Morgan theorem you all know. Okay, if we have P plus Q plus R, P plus Q plus R, and we want to write its complement, so this plus is converted into dot, right? Boolean addition is converted into Boolean multiplication, and we have bar symbol, okay, complement symbol over each variable. So this is P bar into Q bar into R bar. This is the method, okay. So now in this question, what we are getting, this a plus b is in bracket into c bar into d bar. Then we have plus and then bracket. So suppose we take this as one term, say p, and this as another term. So we can say it is p plus q whole bar. Okay, it is p plus q bar. So this can be written as equal to what? Using that concept. So it will be a plus b into c bar d bar whole bar. Okay, it is p bar, and this plus will be converted into dot. So let us use a bracket here. Now this e plus f bar whole bar. So we have used the De Morgan theorem here. We have converted this plus symbol into dot, and on both the two terms we have applied the complement symbol. Okay, equal to. Now here a plus b, treat it as a single term, then dot, then dot. So we are having three terms having dot and over our bar. So using this formula, this can be written as what? A plus b whole bar. Okay, a plus b whole bar. Then this dot can be converted into plus. C bar bar is c. Then this dot in plus. D bar bar is d in bigger bracket. And dot here also use De Morgan theorem. So E bar dot F bar bar is F. Okay, F bar bar is F. So it is equal to what? Again using De Morgan here. So A bar into B bar plus C plus D, and then E bar F. E bar F. So which answer is matching here? We can see C answer is matching with the correct answer. So that is our right answer. Okay, so in your exam, such simplification, minimization is important. You may get question based on that. Simple question you will get. Okay, now let us see next question. So write the answer immediately. Express the Boolean function f equal to a plus b bar c as a sum of minterms. इसको लिखना है आपको sum of minterms की फॉर्म में. So what is the right answer you are getting? Sum of minterms means canonical form. We are having a SOP form a plus b bar c, and we have to convert that into canonical form or standard form. Okay, in standard form or canonical form, each product term is a minterm, and you know minterm is what? A product term containing all the variables, all the k variables of the domain of the given Boolean function. That is called a minterm. Okay. So what answer you are getting here? C. Roshan is getting C. Okay. Tejaswani Patil, your answer. Akash, Asif, SSJ, Nidhi. All of you write your answer. You should know how to convert a given SOP into canonical form. So all getting C answer? Yes. C is the right answer. So anyone here who is not getting how to write this, who want explanation, please tell me. Anyone? Is there any student in the class who want explanation of this? You just make more variables, right? Here you can use one concept I am telling you, that we have a plus b bar c, right? So equal to, now here a is missing. Okay, so what we can do, a plus, we can write it 1 into b bar c. Okay, this can be written as 1 into b bar c. So equal to a plus, now 1 can be written as a plus a bar b bar c. Okay, a plus a bar is 1 na? So equal to a plus, now this is a b bar c plus a bar b bar c. Now similarly you have to introduce B and C here also. Okay, first AB plus AB bar, then ABC plus ABC bar plus AB bar C plus AB bar C bar, and then plus this. If two terms are repeated, write them once, so you will get C answer in this concept. Now let us see our next question. So one more point important here. I want to tell you, uh, to express SOP into canonical form, to express POS into canonical form, to write the complement of a SOP, to write the complement of POS, to convert SOP into equivalent POS. All these are important concepts and principle of duality also. Okay, to write the dual of an expression. So all these things you have to keep in your mind. Okay. So now let us move to next question. So here we can see a waveform. So this is signal A. Okay, this is signal B and this is signal Y. By looking at this waveform, you have to identify the logic gate. Okay, just see the waveform and identify which logic gate will produce this output Y if A and B are applied as input. Which logic gate you will get here? Tell me. Which logic gate you people are getting here? A, B are input, Y is the output. Okay, SSJ is writing something. Everyone present should write their answer, what answer you are getting. Okay, you should be able to identify the logic gate by you looking at the waveform. Explain it, sir. Okay, okay, no problem. So Roshan, you can see the waveform. Here we are having A equal to 0 up to this point. A is 0, right? And here B equal to 0 and this is 0 and sorry, initially Y is 1 and here it is becoming 0. Okay. So first of all, A is 0. We can see A is 0. So I'm writing here A, B and Y. Okay. So initially what we are observing that A is 0 here, right? 0. And B is also 0. Both are 0 and output is 1. So Y equal to 1. Now after this transition, okay, there is a change in B input here. So now what we have, A is still 0, but B has become 1. So A 0, B 1. Output is still 1. So again we are getting Y equal to 1 here. Okay, it is 1. Now here we can see a transition here. So A has become what? 1. And B has become 0. And output is still going to be 1. 1. And here we see A is 1, B is 1, but output is 0. So 1, 1, 0. So which logic gate has this truth table? Roshan, can you identify which logic gate is this? So 0 into 0, 0 complement 1. 0 into 1, 0 complement 1. 1 into 0, 0 complement 1. 1 into 1 complement 0. So NAND gate. You can see it is what? NAND gate. Okay, very good. So now let us see next question. One important point I want to tell you people, in your exam they can give you like definition, like they can write in some logic gate. Okay, when all the inputs are of this form, then output is this. Okay, if one of the input is of this form, output is this. So in this manner they can define something and then they can ask you which logic gate is that. So you should understand the logic truth tables of all the logic gates. This is important. Okay, now come to next question. So what is the answer here? If you get this question, master slave flip flop is also called what? Master slave flip flop का दूसरा नाम क्या होता है? What do we call it? Pulse triggered or latch or level triggered or buffer? So which answer you will give in exam? So Here answer is what? Write your answer in the chat box, all of you. So master slave flip-flop is also called pulse triggered flip-flop. Okay, it is not level triggered here, it is pulse triggered flip-flop. Remember this point. Okay, pulse triggered flip-flop. A is the right answer. So read about master slave flip-flop again and remember this name. Now see next question. So try to solve this question and tell me the answer. So what is the right answer of this question? All of you try to compute and tell me the answer. Done? What is the right answer here? Nidhi, Tejaswani, Asif, Akash, SSJ, Roshan, Bipul, and so should I explain it? How to solve this problem? We are given the connections at the input of the circuit. Obviously, circuit consists of two synchronously clocked JK flip-flop. So it means both receive the same clock pulse. So this is a synchronous circuit, synchronous counter. It may be okay. So what happens in synchronous? All the flip-flops, we are having here two flip-flops and two JK flip-flops. So all the flip-flops will change the state simultaneously. Okay. So without drawing the circuit, I can explain it. I can get the modulus, but I want to make the circuit also to get you more clarity. Okay. So what is here? We have JK flip-flop, right? So let us have one JK flip-flop. J naught, K naught are the inputs. Q naught is the output. Okay, Q naught bar. And we have another JK flip-flop. So J1, K1, Q1, Q1 bar, right? Now they both are connected to same clock because it is mentioned here that two synchronously clocked JK flip-flop. So it means they both have same clock pulse. Suppose they both are positive edge triggered flip-flop. So we will make positive edges and this will be the clock here, right? In exam, to solve this question, I need not to draw the circuit. Okay, I'm just drawing circuit to explain you the concept. Okay, otherwise we can solve it directly without making the complete circuit, right? So J naught is equal to K naught is equal to Q1 bar, right? So Q1 bar is connected. Yeah. So Q1 bar is connected here with this J naught and K naught, right? And J1 equal to Q naught. So this one and K1 equal to Q naught bar. Q naught bar. So this is the actual circuit if we draw according to the connections, right? So how we can calculate the modulus? It is not a shift register. In shift register, we use D flip-flop or any other flip-flop in the configuration of D flip-flop. But JK flip-flop here is not in the configuration of D flip-flop. It is not a register, right? It is a counter actually. So our answer will be either this or this. Okay. Out of these two, we have to choose one answer. So let us write here the present state PS. Okay. So Q1 and Q0. Then you write the next present state, then write the connections. So Q1 is the state of this flip-flop. So its inputs J1, which is equal to what? Q0, right? And then K1, which is equal to Q0 bar, and then J0, which is Q1 bar, and then K0, that is also Q1 bar. Okay. Now assume that initially this counter is in 0 state. Okay, both are 0, this 0, this 0. Suppose we have assumed this, that both the flip-flops are initially reset. So we take 0 0 here, right? Present state we take 0 0. So write 0 here, 0 here, 0 here. Okay. Now what if these are 0 0? Then what will be J1? So J1 is equal to Q0. Q0 is 0 here, so J1 is 0. K1 is Q0 complement. So 0 complement is the 1. And J0 is Q1 var, so 1. And K0 is also Q1 var. So 1. This is the input. Now discuss about each flip-flop separately. This is the present state of this flip-flop. Okay, present state is 0 and both the inputs are 0 and 1, J0 K1. So we know that in JK flip-flop, in case of J0 K0 there is no change. In case of J0 K1 there is reset, flip-flop resets. In case of J1 or K0, flip-flop becomes set, so output become 1. And in case of J1 K1, flip-flop toggles, so it changes the state. From 0 it goes to 1, from 1 it goes to 0. This is the characteristic table, truth table of the JK flip-flop, which we should remember, right? So now again see, present state is 0, input are 0 1. So in case of 0 1, reset will be there. So next state will be 0. So here we will write 0. Okay. And present state is 0 and inputs are 1 1. So in case of 1 1, it toggles. So next state become 1. So it means from 0 0 state, this counter is going into 0 1 state. Okay. From 0 0, it is going into 0 1. Now once 0 1 is obtained, again write the connections of the input. Okay. So now J1 is Q0, so 1. K1 is Q0 bar, so 1 complement means 0. J0 is Q1 var, so 1. And K0 is Q1 var, so 1. So now think independently. First, present state is 0, input is 1 0, so set. So it becomes 1. Okay. Present state is 1 and here we have 1 1. So 1 1 means toggling. So it will become 0. So from 0 1 state it is going into 1 0 state. So draw here 1 0 state. Okay. And now if it is 1 0, then again write down the connections. So J1 is Q0, so 0. K1 is Q0 bar, so 1. And J0 is Q1 var, so 1 complement means 0. And K0 is also 0. Now what happens? Present state is 1 of this flip-flop and inputs are 0 1. In case of 0 1, it remains reset. So it becomes 0. Now present state is 0, inputs are 0 0, so no change. So 0 to 0, it remains 0. So next state is going to be 0 0 again. So this is the state diagram. We have got the valid state diagram here. So it is mode 3 counter. It is not of mode 2, it is of mode 3. Now we can verify the behavior after 1 1 also. Okay. Suppose initial state we take 1 1. So if it is in 1 1 state, where it goes, we can verify this also. Okay. For example, suppose I take 1 1 initially. So J1 is Q0, so 1. K1 is Q0 bar, so 0. J0 is Q1 var. Q1 var means 0. And it is 0. So what is the next state? Present 1, input are 1 0, so set, so it goes to 1. Present 1 or 0 0, so no change, so it remains 1 to 1, right? So this is invalid state and it is remaining in the same state, right? It is not going into the valid state diagram. This will be the state diagram of this. So here valid cycle is this one. Okay, 3 will be the mode of the counter. So please tell me, is this clear to all of you? SSJ. How we can get the modulus? By starting from any state, we can draw the state diagram. And state modulus means number of distinct states in the state diagram. In the closed cycle, how many different states we are getting, that is the modulus. Tejaswani, Nidhi, clear to everyone? Okay. Now let us see our next question. So here tell me the answer. What will be the answer of this question? In the JK flip-flop, we have J equal to Q complement, K equal to 1. Okay, K equal to 1. And this Q bar is connected with J input, right? So assuming the flip-flop was initially cleared and then clocked for 6 pulses, the sequence at the Q output will be, what sequence will be observed at the output? So try to find out the sequence at the output. Anyone who got the answer to this question, please tell me. Write your answer in the chat box. Very simple question and very easily you can write the answer. Okay. So flip-flop was initially cleared, na? So initially Q is what? Here we will write Q and then J and then K. Okay. Next state, you can write here also next state. Next state. This is the present state. Okay. So initially it is clear, 0. Q equal to 0. So now QR is what? If Q is 0, QR is 1. So this 1 is connected with J. So 1 here and K is equal to permanently connected to 1. So present state is 0, input are 1 1. So in case of 1 1, what happens? In case of 1 1, it toggles. Toggle means it go to opposite state. So next state will be 1, which become the present state now. Okay. This next state nothing but it becomes present state. So from 0 it is going to 1. 0 के बाद किस में जा रहा है? 1 में. Now when Q is 1, so Q bar is 0. So J is 0 and K is 1. Now in case of 0 1, what happens? Flip-flop resets. Reset means Q becomes 0. So next state becomes 0, which is the present state now. So it means after 1 it is going to 0. Then again same situation will come. Again 1 1. So toggling. So it will 0 1 0 1 0 1 and so on. So which option is matching with this? What will be the right answer? So D is the right answer here. Okay. It will keep toggling. Very good. So now let us go to the next question. So what is the simplified form of the given canonical form? Canonical SOP is given to you. Okay, summation of min terms 1, 5, 6. You can note down 1, 5, 6, 7, 11, 12, 13, 15. These are the min terms here. Okay, so you have to simplify this. You have to write it in minimum form. Okay, so one Vipul is writing the answer. Other students, all of you, please don't forget to write the answer. K-map. K-map is really important. You should have knowledge of solving K-map. Okay, to write the minimum expression from the K-map. So if I draw the K-map for this canonical form, what I write? There are 4 variables. So it will have 16 cells. Okay, n variable K-map has 2 raised to the power n cells. This one. Now in this order we are having A, B, C, D. Okay, so A, B, C, D. 0, 0, 0, 1, 1, 1, 1, 0. And here 0, 0, 0, 1, 1, 0, right? So min term 1. 1 means what is the code? Binary code of decimal 1. 0, 0, 0, 1. So 0, 0, 0, 1. So 1 here. Now we have 5. So what is the binary code of 5? 0, 1, 0, 1. So 0, 1, 0, 1. So here 1. Then 6. So 0, 1, 1, 0. 0, 1, 1, 0. Here 1. Then 7. So 0, triple 1. Okay. So 0, 1, triple 1. Then we have 11. So 1, 1. Sorry. 11 means 1, 0, 1, 1. Right. So 1, 0 and 1, 1. So 1 here. Then 12. So 1, 1, 0, 0. 13, 1, 1, 0, 1. And then 15, 1, 1, 1, 1. This is the entries and remaining all will be zeros. This is a very popular K-map, you know. Whenever we read K-map, then always we solve this problem. Very, very useful problem. So in this case, when we make the grouping, we use the concept of essential prime implicant. So here we can make this prime implicant. This is a quad. This is one prime implicant. This is a pair. This is a pair. This is a pair, and this is a pair. So there are total 5 prime implicant. Okay. In these 5 prime implicant, these pairs are essential prime implicant. You know, essential, 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 essential. So since all the ones of this quad have been covered by EPI, due to this become RPI. So this quad become redundant. Okay, and in any minimum SOP form, we never write the redundant term. We write PI, EPI, all EPI we include, says SPI, some of the SPI we include, RPI, no RPI is included. Okay, so we will write only the pairs, this pair, this pair, this pair, and this pair. Okay, so A cannot be the answer. Now according to each pair, what we are getting here? First of all, this is A, B. C bar. Okay, A, B, C bar. Plus, now this pair, so common is 0, so A bar, C bar, D. A bar, C bar, D. Plus, then we have this pair, so A bar, B, C. A bar, B, C. Oh, plus this pair is what? A. Okay, here A and this CD, A, C, D. So this will be the minimum SOP from this K map. So you can match your answer. What answer is matching with the correct answer? Okay. Now let us see our next question. K-map is really important. You should have knowledge of K-map. You should have knowledge of essential prime implicant, redundant prime implicant, selective prime implicant. Okay. So in this case, which answer you are going to give in exam? Suppose you get this question. So what answer you have to write in the exam? Okay. K-map is used to minimize the number of what? So all of you write your answer, which answer you are going to give in exam if you get this. So functions of 3, 4, 5 or 6 variables. C answer we give. Okay. K-map is used to minimize functions, Boolean functions of 3, 4, 5 or 6 variables. Generally useful up to 5, but 6 also we can use. Okay. So you have to write C answer. Now, what is the answer? Correct answer here. Such simple question you may get directly by looking at the question. You can write down the answer. So such question are also possible there. So immediately write the answer of this question. What is the right answer? A logic circuit that accepts several data inputs and allows only one of them at a time to get through to the output is called what? Which circuit is definition of which circuit is this? Several data inputs and only one of the output. So obviously multiplexer does this function. Okay, you all know multiplexer has several input and selector lines. According to the select line, it select one of the input and transfer the data to the output line. Okay, so these definitions of all the combinational circuits, at least once you should remember all the definitions, right? What multiplexer do, what encoder do, what decoder do, what demultiplexer do, what magnitude comparator do, code converter do. All these basic operations you should understand. Okay, now let us see our next question. So here answer is multiplexer A. So if you have studied A to D converters, those who have studied A to D converter, they have to answer this. Different type of ADC we have. Which one of the following A to D converter does not use DAC? You know, this is also a very important question. In many exam, they generally ask this basic question. Okay, that we have different ADCs. Some of the ADCs have a DAC as the integral part. You know, if I draw a simple block diagram of a ADC, so in ADC we have a D to A converter as the integral part. Okay, DAC. We have some special register or counter here. Okay, the output of the DAC is given to a comparator circuit, and then analog input is applied here, and then using some logic, okay, we convert it here. This is the general block diagram. So in a digital ramp ADC, okay, or counter type ADC, digital ramp ADC, we use DAC. In successive approximation ADC also we use DAC. Here is a register, and counting type ADC we use this DAC. But in single slope ADC or dual slope ADC, we don't use DAC. Okay, so C is the right answer here. Please remember, in single slope ADC or dual slope ADC, we don't use the D to A converter. In all other, like in counter type, in continuous type, okay, and in successive approximation type, we use DAC as the integral part of the ADC. This is the concept. And the fastest ADC, you know, can you write fastest ADC having the highest speed? So flash type converter has the fastest speed, okay. And which one is the slowest? So dual slope is the slowest, but it is very accurate ADC. So these are the important points which you should remember. Now come to next question. So read the question carefully and try to find out the answer. Okay, all of you, try to solve this problem. So anyone who got the answer to this question, please tell me. Clock is given to us and J and K inputs are given to us. We have to decide the output Q. Okay. What will be the output Q at timing about 1 to 4? So Sonam Kumari, your answer is B. Okay. Asif, Akash, Roshan, Tejaswini, all of you write your answer. Then I am going to explain. Very simple question. If you have basic knowledge of JK flip-flop, D flip-flop, T flip-flop, then you can easily solve such question where present state is given, clock is given, okay, and input is given. We can easily decide the output by looking at the truth table of the different flip-flops, okay. Okay, Tejaswini, I am going to explain this. First of all, a JK flip-flop. We are talking about JK flip-flop. So just recall in JK flip-flop, just write in the chat box. If we have J equal to 0, K equal to 0, what happens? Write in the chat box immediately, all of you. In case of J0, K0, what happens? What is the next state? It is equal to present state. There is no change. In case of J0, K1, what happens? J0, K1, flip-flop resets. In case of J1, K0, what happens? Flip-flop sets. And in case of 1, 1, it toggles. Okay, means complement state is obtained, right? So this is the truth table. Now flip-flop is designed to have a negative as triggered. So it will work negative as triggered. The symbol is this one. Okay, if we want to draw, so this is the symbol of negative as triggered. JK flip-flop, you all know J key inputs. This is the Q output, right? Here is the clock. So how does this work? How JK flip-flop work? It check, JK flip-flop check its inputs just before the negative edge of the clock. Just before the negative edge of the clock, changes the output accordingly. And then again it checks the input at the next clock pulse, next negative edge. Okay. So here, assuming initial value of Q is 0, right? Initially Q is 0, Q equal to 0 initially, right? Okay. Now it will work on the negative edge. So mark the negative edge of this clock. So negative edge means a transition from high to low. So this is the transition. So this is the first clock pulse. This is the negative edge. 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 Okay. So just before the negative edge, we can see here just before this negative edge, J is equal to 1 and K is also 1. So what happens? If we have 1, 1 input, it will toggle. So after cycle 1, it will become 1. Okay. So we can say after cycle 1, it will become 1. Now its state is going to be 1. Up to next clock pulse, it will not change its state. It is going to be 1. Now come to second clock pulse. What is happening here? Just before this negative edge, just before check the input. Both our input are 0, 0 here. Okay. This is 0, this is 0. So in case of 0, 0, there is no change. So it is 1. So it will remain 1 after the second clock pulse also. Now it will continue 1. Now come to the third clock pulse. Just before the third clock pulse, J is 0, but K has become 1 here. Just before the third clock edge. Okay. So J0, K1 means reset. So flip-flop resets. So Q becomes 0. And then come to the fourth clock cycle. So just before this, J is 1 and K is 0. In case of 1, 0, it sets. Flip-flop sets. So 1. So 1, 1, 0, 1. In which option you are getting this? 1, 1, 0, 1. That will be the right answer. So write down the right answer now. Which option will give you the right answer now? Tell me immediately. Tejaswini, is it clear to you? Tejaswini, please reply. 1, 1, 0, 1. So A is the right answer. Sonam, Akash, Asif, please respond. Is it clear to everyone? Okay, very good. So A is the right answer. Roshan, A is the right answer. After cycle 1, it is 1. Then after cycle 2, it is 1. After cycle 3, it is 0. After cycle 4, it is 1. Now let us see our next question. So just read this question carefully and try to find out the answer. So in this question, which option will be the correct answer? Please try to find out this. Okay. So Tejaswini, Akash, you are getting A. How to solve this problem now? You know, this is a sequential circuit or combinational circuit. First of all, you tell me, is this sequential circuit or combinational circuit? What do you say? Write in the chat box, please. By looking at the circuit, what will you say? Combinational or sequential? What is your answer? All of you, please tell me. So Roshan is saying combinational. Okay. Other students, everyone who is present, please respond. What will you say about this circuit? Is it combinational circuit or a sequential circuit? One student has answered as combinational. Tejaswini, what is your answer? So it is not a combinational circuit actually. You know, this is the output which is going as the input here. So we can say feedback is going. Okay. So the next state is depending upon this A and B input as well as the present state also. So this is a sequential circuit. It is not a combinational circuit. Okay. Akash also answered combinational. So please clear this concept. We have a feedback arrangement. Na? This Qn is going as the input. So this Qn and A will decide this. and this Qn and a B bar will decide this. Okay, so this is an inverter. You know, there is an inverter here. So next state will be decided by using present state and the external input. So this happens in case of sequential circuit. Okay. Now where do we get the next state? Where is it stage? So next state, present state. There are two things. Both occur at the same place. Whatever we are having, that is the present state, and whatever is going to come, that is the next state. After coming, that become present state, right? So here, this Qn is the present state, suppose, going here Qn, and here it is A, and this is XOR gate. So output will be what? A Qn bar plus A bar Qn. This will be the output of this XOR gate, which will go here, right? Now this Qn is going to this side also, and this is inverter, so B bar is going here, and gate, so it is what? B bar Qn. B bar Qn. Okay. Now this is OR gate. Resultant will give us next state. So we can say that Qn plus 1 is equal to the addition of this plus this. Okay. So we can say it is A Qn bar plus A bar Qn or plus B bar Qn. This will be the next state formula. Now they have mentioned here A comma B comma Qn. So they have created the minterms in this order. First A, then B, then Qn. So in all the minterms here, we will convert this into canonical form, and we will follow the same order A, B, Qn. Okay. So now this is the question of converting SOP into canonical form. So equal to what we can write here? B is missing. So we can write it as A, B, Qn bar plus A, B bar, Qn bar. Okay, plus. Here B is missing. So A bar, B, Qn or plus A bar, B bar, Qn. Okay, plus here A is missing. So A, B bar, Qn or plus A bar, B bar, Qn. Okay, this will be the canonical form, and now you can write the binary code and corresponding decimal number of these minterms. I hope you can answer this question now. So here what we get? 110. 110. 110 is what? 6. In decimal, 110 is what? 6. Then we get 100. So 4. Then 011. So 3. Then 001. So 1. And then 101. So 5. And then 001 already written 1. So these are the minterms 1, 3, 4, 5, 6. So which option is the right answer? Please tell me. So we can see D is the right answer here. Okay. So I hope this is clear to all of you. Please confirm. Sequential circuit concept. Now let us see our next question. So what will be your output here? Please tell me. Very easy question. Just testing of your knowledge and conceptual knowledge. If you know the concept, you can easily answer this question. Okay. This arrow is nothing. You can write just in this form, right? Or so anyone who got the answer here in this circuit, okay, we know different logic gate. All the logic gate are OR gate. You know, by looking at the logic gate, you can identify all are OR gate. So if A and B is 0, 1, if input are 0 and 1, so it means A 0 and B is 1. Then what will be the next state? Okay, if these are the inputs. If this is 1, so 1 plus something is equal to what? In OR gate, if one input is 1, so 1 plus something is 1. So obviously output will be 1. And here also 1 plus something is also 1. So next state is going to be what? 1. So A is the right answer. In OR gate, if any input is 1, output become 1. Simple concept. Testing of knowledge of OR gate concept. Clear to all? Please confirm. Is this clear to everyone? Now come to next concept, next question. So this is our next question. The number of essential prime implicants in the K-map zone. But before this, let us solve some more questions. We will come back to this question again. Solve this. Done? All of you? Signed binary arithmetic, signed addition, 2's complement addition you should know. So we are having two numbers A and B. Both are in 2's complement form. We want to add them and we want to write the answer in also in 2's complement form. So in case of having two numbers in 2's complement form and we are interested in getting the answer in 2's complement form, what we have to do? Okay, first of all, make equal number of bits. So how many bits are there? 2, 4, 6, 2, 4, 6. Already they are having same number of bits. Okay. So then you write the numbers as 1, 0, 1, 1, 0, 1. And then we have 1 triple 0, 1 triple 0 and 1 0, right? Let us add them. So using simple binary arithmetic, okay, we know 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 0 with carry 1, 1 plus 1 plus 1 is 1 with carry 1. Using that concept, we will add them. Okay. So 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 0 is 1. Okay. And 0 and 1 plus 1. I think some mistake I have taken. 1 0 1 1 0 1 and 1 triple 0 1 0. Okay. So 1 1 1 1 0. Now 1 plus 1, 0 with carry 1. Okay. So we are getting a problem here. What is the problem? You know, we are adding two numbers, right? Both have sign with 1. So both are negative numbers. Okay. Both are negative numbers. And here we discard the carry generated. The carry generated. So we discard that. We look at the sign bit. Sign bit is 0. So resultant is coming to be 0. Numbers are negative, but resultant is showing positive. So there is a problem. And this is called problem of overflow. Here in this addition process, overflow has occurred. ओके क्या हो चुका है? ओवरफ्लो आ चुका है. अगर ऐसी सिचुएशन आती है, सपोज वी गेट 1 हियर, suppose it is not 0, it is 1, then this is the answer. Discard the carry, resultant is the answer, no problem. But if these two bits are 1 1 and here we get 0, or these two are 0 0 and here we get 1, then there is a problem of overflow. So here we are suffering with problem of overflow. In that case, what we do, we take one more bit, we increase the bit. Now in 2's complement form, how we can increase the bit? We can copy the MSB to the left side. Okay, so this number will be written as 1101101, and another number is 11000010. Now we will perform this addition. Okay, so it is 1 1 plus 1 0 with carry 1, 1 plus 1 plus 1 1 with carry 1. Okay, so this carry is discarded, and now we can see here it is 1 1, so it is also 1. So no problem now. This is the answer, but I think options we have taken wrongly. Okay, so leave the options. This will be the total sum. Okay, please understand the concept. Okay, options में कुछ mistake हो गया शायद. Leave the options. Clear to everyone? 2's complement addition directly you should have a practice. Now overflow is what? That also you have to revise. So now tell me the answer of this question. So what will you do here? Output Y of the circuit shown we have to compute. So you should know about decoder, about multiplexer. Okay, you know, in this decoder, these bubbles represent that output of the decoder are active low output. Okay, this is a decoder with active low output, right? This is XOR gate and this is the multiplexer. So first of all, let us write this output. So if we don't have bubble, then we know that this output is Y naught equal to A bar B bar A bar B A B bar A B. But we have a bubble, so it is what? A bar B bar whole bar, due to this inverter. NAND gate we are using actually here, and this is what? A B bar. This is A B bar. It's whole bar, and we have to do their XOR operation. You know, this is the XOR gate. So this, can you simplify this? It is what? If you write the XOR gate, so in XOR what we do? One input into complement of the another. Okay, here it is suppose Y1. So I am writing Y1 here. You know, P XOR Q is what? P XOR Q. It is P Q bar plus P bar Q. Okay, P Q bar plus P bar Q. This is P XOR Q. So use that concept here. This, that is A bar B bar whole bar into its complement. So its complement will become A B bar plus. Now this into its complement. Now this, that is A B bar whole bar into its complement, that will become A bar B bar, because bar will get cancelled. So equal to, this is using the De Morgan theorem, A bar bar A plus B. So it is A plus B into AB bar, or plus, here we are getting A bar plus B, A bar plus B, A bar plus B into A bar B bar. Okay, so equal to, now this A into AB bar, so AB bar plus B into B bar is 0, so 0. Okay, plus, and this is what? A bar B bar, A bar B bar, or plus B into B bar is 0. Now B bar can be taken common. So equal to B bar is common. So we get A plus A bar, that is 1. So equal to B complement. Okay. So here we are getting output Y1 as B complement. Now what is this? This is AB bar. Okay. AB whole bar. This one. So now you can write the output of the circuit Y equal to, I hope you can do. So what is the answer you are getting? Please confirm. Bipul is getting B answer. Any other student? Now I hope you can simplify. Y1 is B bar, this one. Okay. And this is A, S equal to A. So final output you should be able to write. So here we can write the final output. This Y equal to S bar. S bar means A bar. S bar का मतलब A bar into Y1 जो B bar है. Okay. और प्लस S का मतलब A और इंटू I1 कितना है? ए बी का होल बार, ए बी का होल बार ये. सो इक्वल टू ए बार बी बार और प्लस ए इंटू, यूजिंग डिमॉर्गन इट इज ए बार प्लस बी बार. सो इक्वल टू ए बार बी बार प्लस ए इंटू ए बार इज 0 प्लस ए बी बार. So again we are taking B bar as common. So A bar plus A is 1. So B bar is the right answer. Option B, right? This is the right answer. So you should have knowledge of how to write output of the decoder, output of the multiplexer, all the combinational circuit output. You should have knowledge. Now let us move to next question number 21. Okay. So this is question: how many 4x1 multiplexers are required to design 64x1 mux? This is a simple question. So all of you please write the answer immediately. How many 4x1 multiplexers are required to design 64x1 mux? All of you tell me the answer. Which answer you are getting? Fast. Okay, Roshan has written the answer. Very good. So this is the correct answer, 21. How do we compute this? We just divide this 64 by 4. Okay. So we are getting 16. So in level 1, in first stage, we need 16 multiplexers. In the next stage, 16 by 4 is what? 4. So level 2, in level 2, we need 4 multiplexers. Then 4 by 4 is 1. So in the last level, level 3, okay, last stage, we need 1. So total number of multiplexers required is 16 plus 4 plus 1, that is 21. A is the right answer. Okay. Now what is the answer here? Octal equivalent of the hexadecimal number. Please write your answer immediately. Hexadecimal to octal conversion. Done? So which is the right answer here? You all must remember how to convert octal to hexadecimal number or hexadecimal to octal. So here we are given a hexadecimal number. We can convert that into binary, and then from binary we can convert it into octal. So please write the answer. Anyone who got the answer? What is the right answer here? Okay, Roshan is getting C answer. Yes. So I hope all of you can solve this. First convert that into binary and then make groups of 3 and then convert into octal. All of you can do it. Decimal equivalent of the octal number. Okay, so octal to decimal conversion. We are having a octal number 312. We want it into decimal. So what is the answer? All of you calculate the answer and write it in the chat box immediately. Octal को कैसे convert करते हैं decimal में? Okay, any base R to decimal conversion you should know. Binary to decimal, octal to decimal, hexadecimal to decimal, all these conversions. Okay, so SSJ is getting B answer. I hope all of you can solve this. We are having 312 na octal number. So write a to the power 0, a to the power 1, a to the power 2. So 3 into 8 square plus 1 into 8 to the power 1 plus 2 into 8 to the power 0 and resultant is 202. So B is the right answer. Now what is the answer to this question? All of you, please. The number of Boolean expressions. So this is a formula, you know, number of Boolean expressions or Boolean functions that can be formed using n variables. Using n variables. So 2 raised to the power, 2 raised to the power n. Okay, this is the formula. So if we have n equal to 3, so 2 raised to the power 8, so 256. So C will be the right answer here. Okay, simple. Now what is the answer of this? In case of demultiplexer, what we have? Demultiplexer is a what? One to many. It has one input and transfer data to one of the several output. Okay. So one input, many output, right? B is the right answer here. Basic knowledge you should have. Now just see this circuit and tell me the answer. Okay. By looking at this circuit, what will be the output of the, what will be the right answer here? Which answer you are going to take in exam if you get this question, suppose? Okay, very good. So SSJ has written the right answer D. You know, this is a what? This is a demultiplexer. Okay. So using the select lines, it select and transfer the data to the selected output. Okay. So if we take A1, B0, so in case of A1, B0, it will be transferred to Y2. Data will go to Y2. So Y2 will become 1 because data is 1. So Y2 is 1 and all other remain low. All other output remain 0. So D is the right answer here in case of multiplexer. So we have solved these important questions and now there was one question. I want to give you this problem as a homework actually. This is important question to test your actual knowledge of EPI, RPI, SPI. Okay, very important question. So please take the picture and try to solve it at your home. You have to try to find out the essential prime implicants in this K-map. Number of essential prime implicants in this K-map. So this is your homework. I have prepared this for you as a homework. Okay. And finally, I'm not going to explain. You have to think of first. So can you do it? You first revise EPI, RPI, SPI concept and then solve this. Okay. I hope you enjoyed all these questions, and these will help you in your exam preparation. Okay, so now I am ending this class, and we will meet in the some another class and discuss another questions. Okay, all the best all of you. So रोशन 3 क्या लिखा है आपने 3 इसका आंसर लिख रहे हो क्या इज दिस आंसर 3 आर यू सेइंग रोशन so you are also writing 3 3 is not the right answer, you know. That is why I have prepared this for you. Think, okay, take your time, have your dinner, and then solve it. And those who are in WhatsApp group of NIC by YourPedia, they can send the answer in that group, okay, by solving properly. Okay, then I will explain. Okay, good night all of you. All the best for your exam.